EV Expert, e-learning, diagnosis. Systems specialized for EV. Overview. Most of the functions displayed on an EV's instrument cluster are like those of ICE vehicles, but there are also indicator lights for EV-only functions. Instrument cluster, Smart Eco Pedal Guide, DTE, distance to empty, utility mode, etc. Let's take a look at systems unique to the Kona EV. Systems specialized for EV. EV indicators. You can check the distance to empty, DTE, from the center of the instrument cluster. From the viewpoint of EV customers, the DTE is the most important information and is located in the center of the cluster. On the right side of the instrument cluster is the SOC gauge. On the left side of the instrument cluster is the power charge gauge. And on the lower center of the cluster is the regenerative braking level indicator. This is the charge indicator. It lights up when a charger is connected. This is the high voltage battery level warning light. It lights up when the battery SOC is less than 8%. This turtle-shaped indicator is the power down warning light. It lights up when the battery SOC is less than 5%, when the battery temperature is too high or low, or when cooling system fails. This is the EV-ready lamp. It lights up when driving is possible. This is the EV system warning light. It lights up when the EV high voltage related system fails. This is the integrated warning light. It lights up when the ADAS related systems, such as SCC or FCA, or other driving safety related systems, such as headlamp failure occurs. Let's take a look at the instrument cluster messages related to EV functions. For safety reasons, charging is only possible in P range. This is the message displayed if the charger is connected when the vehicle is not in P range. This message is displayed when supplemental charging function of the 12-volt auxiliary battery is activated. This measure is displayed together with the battery SOC warning light when the high voltage battery SOC is less than 8%. This message is displayed together with the battery SOC warning light and power down warning light when the high voltage battery SOC is less than 5%. This message is displayed when the battery temperature is very low and when SOC is low. A is displayed during EV off status and B is displayed during EV on status. The last one is the message displayed when the high voltage battery temperature is very high. These are the instrument cluster messages related to EV functions. Systems specialized for EV. Smart Eco Pedal Guide. The Smart Eco Pedal Guide is a function that provides a driving guide so that a driver can drive economically more actively. In this function, the VCU displays an efficient driving guide on the instrument cluster based on signals about driving conditions, such as accelerator pedal, vehicle speed, and road type. However, there are matters to be noted. Drivers can use Smart Eco Pedal Guide only in Eco or Eco Plus mode. However, this is not available when SCC is set. Systems specialized for EV. Distance to empty, DTE. As mentioned earlier, DTE is very important information to customers. DTE stands for distance to empty. However, this means the distance the vehicle may be able to travel rather than the distance the vehicle is able to travel. Why is this so? Let's take a look at an example. If the DTE indicates 100 kilometers, it means that the driver can travel 100 kilometers. However, the driving distance may be longer or shorter depending on the driving tendency or the drive mode setting. What if a customer's usual driving patterns are aggressive and customer always turns on the heater even in a little chilly weather? In this case, the DTE is likely to be much shorter than that under average driving conditions. The DTE is calculated by the VCU. The VCU estimates electrical efficiency using the SOC of the high voltage battery, the air conditioning operation of the DATC, and the driving route setting of the AVN. Then, the VCU calculates the final DTE by applying a weight factor using the average value of the past 20 driving histories. Therefore, the DTE may vary depending on HVAC setting, navigation setting, drive mode setting, driving patterns, and ambient temperature. Then let's take a look at how DTE changes according to vehicle settings. How does DTE change? Situation 1. Setting a destination for navigation. DTE changes according to the route setting when setting a destination. DTE changes according to whether the route follows a highway or local roads. Let's see on the screen now. If the destination is set to use a highway, DTE drops from 397 kilometers to 393 kilometers. This is because the EV has less electric efficiency when driving at high speeds. Now, it is set to use a local road. You can see that the DTE increases from 393 kilometers to 407 kilometers. Due to the characteristics of EVs, compared to highway driving conditions, the average driving speed of local roads is relatively low, and the frequency of regenerative braking is high, which may increase the DTE. Situation 2. Driver's driving history. The driver's driving history also affects DTE. The past driving electric efficiency is calculated by the VCU by reflecting the driving history of the past 20 times. Therefore, the DTE may be displayed higher or lower according to the past driving patterns of the driver. You can find the star indicator in the past driving history data, which indicates the most efficient driving history. So, is there a way to reset the driving history? Go to Software Management and select Reset of Learning Data of Available Distance for Driving from the VCU LDC. Perform this procedure with EV on status and check the enable condition before reset. Set EV off status and set back to EV off status 5 seconds later, and the data will be reset. You can also initialize DTE history in the AVN, EV, Eco Driving, EV Economy History. Press the List button and select Delete History. Situation 3. Ambient temperature. The ambient temperature affects the DTE. This is because the temperature greatly affects the efficiency of the battery. Therefore, DTE decreases in winter than in summer. Situation 4. Regenerative braking. Regenerative braking can affect DTE. The amount of energy generated during regenerative braking or coasting is converted into the mileage. This is added to the DTE and displayed on the instrument cluster. Situation 5. Drive mode. The drive mode setting also changes DTE. Driving characteristics such as steering force and acceleration performance may be changed by the drive mode setting. Drive mode has Eco, Comfort, and Sport modes by default, and Eco Plus mode can be selected by pressing and holding the drive mode switch. As you can see on the screen, DTE changes depending on the drive mode. Now let's take a look at the detailed setting of each drive mode. The maximum speed limit, regenerative braking level, and air conditioning of each mode can be set in the USM. Eco mode can set air conditioning, regenerative braking level, and maximum speed limit. Comfort or Sport mode can only set air conditioning and regenerative braking level. Systems specialized for EV. Utility mode. In the case of an internal combustion engine vehicle, in order to enjoy movies, music, etc., while using air conditioning for a long time, the 12-volt auxiliary battery discharge should be prevented, so the vehicle engine must be started. Therefore, noise and vibration of the engine and harmful exhaust gas emissions cannot be avoided. However, since EVs use high-voltage batteries, you can use EV without such restrictions. This is utility mode. Utility mode is available by USM setting in the EV Ready status and P-Range status. Once the utility mode indicator lights up, the parking brake engages automatically for safety. In this mode, it is impossible to drive the vehicle, but various convenience devices using high voltage can be used. Utility mode is released by switching back to the EV on state after EV off. The driver cannot find the utility mode operation menu in the EV on state. This is because the utility mode menus in the USM only in the EV Ready state. To use utility mode during charging, you must enable utility mode in the EV Ready state before charger connection. There is one thing you should pay extra attention at this time. This is the case of charging the high voltage battery while using the utility mode. The utility mode was activated in the EV Ready state, but after the charging is completed, the EV is switched to the EV on state, so there is a risk of discharging the 12-volt auxiliary battery, so it is not recommended.